Hello, today we're going to talk about inequalities and then we're going to go into some practice of how we graph or what inequalities look like when we graph them. Okay? So what are inequalities? Inequalities are, in short, it's a value comparison statement using one of four symbols. So it's using one of these symbols. What they mean. This first symbol, this symbol is our greater than symbol. Okay, this is the greater than or equal to symbol. Okay, and then the other two, this one, this is what we call our less than symbol. And last but not least, again, it looks similar to that previous one. This is the less than or equal to symbol. So when we read these, this is how we read these symbols. Okay, all right. So let's go ahead and I'm going to start with an example with just values, just do a couple examples here. And we're going to identify which mathematical symbol or which inequality symbol will finish off the statement correctly. So when we have inequalities, we start from the left and read it left to right, just like we were reading a book. So starting here, we have a -4. And I need to fill in the blank here. -4 is blank, blank, blank to -5. Now, it's not equal to, so in this case, we can't use the equal sign. That's when we know it's an inequality. So we just kind of go through the list until we understand, okay, which one is greater? Well, when we're talking about negatives, then, all right, reading this, we would say -4 is greater than -5. And we can verify that on the number line. Here would be our 0, -1, -2, -3, -4, -5. Okay, so here's -4 and here's -5. Well, this -4 here is greater than -5. Okay? Because when we're starting at -5, we have to go in the positive direction to get to -4, to go increase. So that means that the -4 is greater than -5. Okay? Let's go to the next one. We have -2/10 and -2/100. Again, we have to kind of jump back and say, okay, first I have to picture this on a number line. And it's perfectly acceptable to draw yourself a number line here. So here's 0. I like to start with 0, and I noticed we had two negatives, so I kind of moved my 0 more to the right-hand side of my number line. If I have 1 here, so -1, where would -2/10 be? I'm picturing, okay, divide this into 10 different sections. 1, 2. Okay, so -2/10 would be here. Where would -2/100 be? Now I have to imagine drawing 100 little spaces. And how would that look? Well, they would be much smaller spaces. So I would probably go 1, 2, maybe right here is the 200ths. Okay? Knowing that my the least numbers or the lower numbers go on to the left and my greater numbers go to the right on a number line, I know that if I have this point right here, which was our -200ths, and I'm going to go to the 2/10ths, I'm going to go in the negative direction. Okay, which tells me that this 2/10ths is actually less than negative 2 hundredths. So negative 2 tenths is less than negative 2 hundredths. Okay? Now, when we're working with inequalities, yeah, sure, less than and greater than work out great when we have numbers here, or values. What if we have what's called a changing or independent or dependent value, something that changes? Okay? Or maybe there's more than one answer. That's where our greater than or equal to and less than or equal to really come in handy. So what I'm talking about here, for example, is when we go to a restaurant, you have the kids menu, and the kids menu says that you have to be at most 12 years old in order to order off of the kids menu. What does that mean? Well, obviously that doesn't mean that every single kid has to be 12 and 12 exactly in order to order off the kids menu. That means that if you want to order the kids menu, you can be 12, but you can also be 10, you could be 8, you could be 2, I mean, you could be 2.5, okay? You could be 10 years old in one day. I mean, it's really, we have a lot of different values that can satisfy this. Okay? So what we say is, rather than writing out a whole list of possible numbers, we say that the age of the child, so we'll use A for age, needs to be less than or equal to 12. And how that would look on a number line, we would go to 12 on that number line, and we'd say, okay, if the kid walked in and ordered off of the kids menu, if they're 12, can they order off the kids menu, or are they supposed to? And the answer is yes, they can order off of the kids menu. It says at most. Okay, so you can be 12, you just cannot be older than 12, or you're not supposed to be older than 12. Okay, so we're going to go ahead and put a closed dot here to represent that yes, 12 is a solution to this statement. You can be 12. So notice the closed circle. What are the other ages? We said 10, we said 8, we said 2. Okay, where are those on the number line? All of those other possible ages are all to the left side of 12. So rather than putting point dot after dot after dot all over this number line, we just put a straight line. We color in the entire thing, and that tells us that you can be any age as long as you are not over the age of 12. Okay? So you can be 10, you can be 10 and a half, you can have that funky thing where you're counting your days, okay? As long as you are not older than 12, you're good. So this is what we utilize in order to represent a given inequality statement. So here's our inequality statement that I just boxed. To represent that, we use a number line, and that graph, the blue here, represents all of our possible ages in this case that children can be if they want to order off of the kids menu. And that's really what we're going to be talking about. So how can I keep all these four different signs straight? What we're going to do is we're going to draw a little table here. And that's going to help us, at least for now, we can reference it to see what the symbol looks like. How am I supposed to read this symbol? Okay? And what's the graph going to look like of this? So if I graphed it correctly, what would it look like? So this blue part right here, what would it look like? Would it be open circle, closed circle, a left or right? All right. So let's go ahead and I'm going to start with this symbol. Now, if you remember this symbol, that's right, it means less than. Okay? So we're just going to write less than. So anytime I see this symbol in math, I'm going to read it as less than. Now, what is this graph going to look like? Well, again, we're going to graph it on the number line here, okay, because we're dealing with values. And say I have a certain number. You know what? For our examples, we're just going to use 2. Now, we know this number can change, okay? But we have a certain variable. It can be any letter, really. Maybe it stands for the number of bananas I eat a day. I don't know, okay? And then this number over here can change. So how would we read this? We would say B is less than 2. So B is less than 2. That's how we would read this statement. The graph, we're going to start at 2. Whatever B is, can it be equal to 2? And the answer is no. So rather than putting a closed circle, we're going to put an open circle, which means, hey, as soon as you hit 2, no go. You can't do it. Okay? What other numbers could it be? Let's see. If I put 3 here, is 3 less than 2? And the answer is no. 3 is not less than 2. 3 is more than 2. So we would have to go into the other direction. We'd have to go to like 1 or 0, -1, okay? All of the numbers to the left of 2. So we would draw that graph straight, and we'll include the arrow because we're not real sure what we're talking about here. So we don't know when to stop. We're just going to keep on going. All right. And that's what the graph would look like. We say it's an open circle, and then it goes to the left. Okay. All right, the next one here, it looked similar. And let's use, I don't know, let's use R and say 2 again. We're going to just keep that 2 continuous, but please remember that these change. Okay, the variable and the number change depending on the situation. All right, so how would this read? This would read R, whatever R is. It is less than or equal to 2. Okay, and that's how you would read it. R is less than or equal to 2. Okay. So again, we're going to use that number line to represent all of the possible numbers that R can be. We still don't know what R means or stands for, but what are all of the possible values it could be? Could it be 2? Is R less than or equal to 2? And turns out 2 is equal to 2. So yes, R could be 2. So we're going to have that closed circle. And that takes care of that equal to part. Now let's take care of the less than part. Think of a number that's less than 2. Where on the number line is it? Is it to the left or to the right? It is to the left. So we're going to color in to the left of 2. And that's going to be our graph here in the blue. Okay. All right. Next up, let's say we have S, and then let's do this symbol. Now again, if you remember here, that S can be any variable. It doesn't have to be S. It can be B. It can be R. It can be X. Okay. So how would we read this? Remembering that this symbol right here, we're going to say greater than. So we would read S is greater than 2. Just like so. Putting it on the number line, again, keeping in mind that this 2 is not constant. It just depends on what value we have in our inequality statement. All right. Now, what kind of values can S be? Can S be 2? So if I put a 2 here, is 2 greater than 2? And it turns out, you know what? If I have 2 Skittles, I have 2 Skittles. 2 is not bigger than 2 by any means. So to represent that it cannot be 2, or it is not 2, we open the circle because it can get as close to 2 as possible, but it cannot be equal to 2. All right, now what values can we think of that are greater than 2? And I think of automatically like 4. So, okay, so where would 4 be on the number line? It'd be this direction. And that's how you would graph that one. Okay. Last but not least, if we needed to graph one that looked like this. And I'm going to use -2 just to kind of change it up a little bit. Okay, so how would we read this? X is, and then we would say greater than, read the symbol, so X is greater than or equal to -2. Okay, so on a number line, we've been working with 2 clear over here. Well, now we're at -2. Okay, so rather than, remember this number line, we can move any direction we really want, so you don't always have to put more than one number. All right, so what would this graph look like? Well, it would look very similar to greater than, except in this case we're at -2, and it can be equal to the -2. So X can be -2. So we're going to close that in to represent that it can be -2. So which direction is greater than -2? Over here we got like -4, -6, and so on. Those are all less than -2. So we're going to go to the right. Okay? Hopefully you've copied this down. Let's go ahead in our worksheet. We're going to practice this a little bit. Now that we've discussed this, let's go ahead and practice